السلام عليكم ورحمة الله تعالى وبركاته. In a series of lectures concerning the course Applied Pharmacognosy, in this seventh lecture, we will talk about structural elucidation of secondary metabolites or structural elucidation of natural products. Structural elucidation means determining or identifying the chemical structure of compound present in natural sources, mainly in plant and marine organisms. Identification of the chemical structure can be carried out by using spectroscopic techniques such as mass spectrometry, MS, UV, visible spectrometry, ultraviolet, والNMR اللي هو nuclear magnetic resonance, and IR infrared spectroscopy. The content of this lecture can be divided into two main parts. Part 1, we talk about the purification and preparation of the isolated compound for structural elucidation, and the second step is about the principle and application of these spectroscopic techniques, including IR, NMR, UV, and MS spectroscopy. As a general introduction for structural elucidation of active ingredient or natural product, assay for natural product can be divided into two classes. Class 1, assay of group of constituents, or we said assessment of total constituent present in plant sample, and the other class, assay of specific component or assay of isolated compounds. Assay of group of constituent or assay of total constituent we discussed in detail in the lecture about structural quantitative determination of active ingredient. For example, determination of total alkaloids in their natural sources such as belladonna, or determination of total glycosides in digitalis, for example. This group of assays can be include a biological assay, which is applied for potent crude drugs and fractions, such as determination of digitalis or vitamins or sabonins based on their biological activity, or maybe by using chemical assays, which involve volumetric titration, acid-base titration, as example, or parametric titration, determination of free alcohol from peppermint oil. Also, a safe group constituent can be achieved by physical techniques or physical assays, such as use of NMR to distinguish exudate from various regions producing famine, through determination of distinguishing the chemical structure, mainly the carbon and hydrogen bonding in the molecule. The second class, let's say for specific component or for isolate, for example, determination of resin being isolate from Rauwolfia species or all Rauwolfia plant. A specific assay, this class of assays, we speak in detail in this lecture. We use mainly physical techniques for structural elucidation. Physical techniques used in structural elucidation, including spectroscopic techniques such as UV, IR, NMR, and mass spectrometry. which are used for identifying the group of active constituents. Structural elucidation for natural products involve identifying and determining the chemical structure of compounds derived from natural source, mainly from plants and from marine organisms. The importance of structural elucidation is to understand the biological activity and potential application of this compound in nature. Several physical spectroscopic techniques are used in characterization of natural products, including UV spectroscopy, IR spectroscopy, MS, and NMR spectroscopic techniques. Before starting the procedure for structural elucidation, we need to be sure that the hydrogen compound is pure single compound. And this is achieved by using chromatographic analysis using various analytical techniques, such as the use of uh, TLC, and we determine the purity by using one spot of present one spot of sample in three different solvent or different mobile system. In this case, we make sure the compound is pure. Another technique can be used for assurance that the compound is pure and single by using two-dimensional thin layer chromatography, and if at the end of analysis the chromatogram contains one spot, that means compound is pure. Or by presence of one peak when we use HBLC or gas chromatography. Further confirmatory test can be achieved by using thin layer chromatography and by measuring RF value in TLC in three different mobile phases. If we have the same RF value in three mobile phases, that means the compound is pure. Also confirming is the compound is fluorescent or non-fluorescent by using short UV light, UV spectrum, UV spectrum, using UV lamp. Also by reaction with a specific spray reagent to ensure the quality of the isolated compound, if it is single or mixture compound. After that, we confirm the other physical properties for the compound by determining its nature, physical nature. Is it a crystalline or powder or oily compound? Also determining the solubility and melting point and optical activity. Through these techniques, or mainly spectroscopic techniques and physical properties, we make sure the compound is pure single compound and it is ready for the next step, اللي هي the structural elucidation, or determining the nature or the chemical structure of the compound. After we performing uh, purification and we make sure that the compound is single and pure. And before proceed to further structural elucidation steps, we have to make sure the purified compound is not previously reported in literature, because the different compounds either uh, previously reported or new. So if it is new, we can proceed for structural elucidation. The step in structural elucidation can be divided into two steps. The first step, determining the molecular formula by using mass spectrometry, which is known as elemental analysis. And the second step, using spectroscopic techniques to determine the chemical structure, the presence of functional groups, and the configuration or the link between carbon and hydrogen atoms using spectroscopic techniques. Generally, spectroscopy means the study of interaction of electromagnetic radiation with atoms and molecules of chemical compounds. The interaction between electromagnetic radiation and the atoms and molecules may be direct or indirect. Indirect interaction and measurement of electromagnetic radiation as in MS, and the direct interaction as in other spectroscopic techniques like UV, IR, and NMR. In general, the electromagnetic spectrum ranges from long radio waves to gamma rays. The long radio wave, or actually the short radio wave, can be applied in NMR to determine the carbon and hydrogen atoms that are present in the molecules. And microwave, also used in microwave spectroscopy, which determine the length of the bond and the angle of the bond, but is outside the scope of this lecture. Infrared applied in IR spectroscopy determines functional group present in compound. Also, the UV light used in UV visible spectroscopy will determine the presence of functional groups such as the pi bond and aromatic with mainly for compounds with that having spectroscopic techniques used in structural elucidation of natural products, which we describe or speak about in details in this lecture, is the use of ultraviolet visible spectroscopy, UV visible, which is useful for studying the conjugated system and chromophores. Also, we speak about IR spectroscopy, infrared, which is used to identify functional group within the molecule, determine the carbonyl, carboxyl group, aldehyde, keto group, and so on. The NMR spectroscopy provide detailed information about the molecular structure of the molecule, including arrangement of atoms and the type of carbon and hydrogen present in the molecules. Mass spectrometry determines the molecular weight and the composition of the compound. In general, these methods are used in combination to achieve a comprehensive understanding of the compound structure. Because no one spectroscopic technique is useful to or enough to determine the whole nature or comprehensive nature of the compound. We need a combination of these techniques to identify the structure of the compound. The ultraviolet visible spectroscopy, it is a wide analytical technique used to measure the absorption or transmission of UV and visible light by sound. In its principle, the UV spectroscopy, when the visible light or UV light pass through sample, uh, The molecule absorb the light, and this absorption causing electron in the molecule or the sample to become transition from lower to higher energy state because they absorb the UV and visible light. Also, in the principle, in order to determine the structure of a functional group present in compound, the solution of the sample should be very dilute. So, in this case, the solution obey or follow B's law. Clear that not interfering substance are present during the measurement. The another thing, besides the dilution of the solution, we ensure that the solution is free from interfering substances, such as fractions or particles of silica that result from TLC during TLC purification of the solute. Because the interfering substance may affect the absorption of UV light and then affect the response obtained by the UV detector. The absorption pattern of UV visible light is unique for each molecule and for each sample. The resultant response of absorption for UV visible light can result in UV spectrum or UV plot or UV graph. For example, the UV spectrum of a NAD plus compound, we have two axes. In x-axis, we find the wavelengths of UV visible light in nanometer, and in y-axis, we find the absorbance of this light. Each molecules have unique pattern of absorption, and the absorption at highest level, known as lambda max, is unique for determination of the compound. Also, in principle, for UV visible spectroscopy, each compound which can be detected by UV visible spectrometer should have a chromophore. Compound should have chromophore. Chromophore, which means the part of molecule will provide the main UV absorption, and it's coincide with the lambda mass. Usually, the chromophore may be conjugated and saturation, such as bi-bonds in dienes and polyenes, and in enones and aromatic groups. Also, another important terminology in principle of UV spectrometry is auxochrome. And auxochrome means that the group which is self does not absorb significantly the UV light in range from 200 to 800 nanometers, but which affect the spectrum of chromophore to which is attached. Example of auxochrome, uh, the alkyl group or methyl group, hydroxy group, amino group, and nitroso group. Auxochrome can have the following effect, which means a type of effect produced by auxochrome groups is a shift. Shift means the lambda max wavelengths at the maximum absorption to longer wavelengths, result in the shift of lambda max to the side of the highest level of wavelengths, which is known as redshift or bathochromic shift. A shift to shorter wavelengths, known as hypsochromic shift or blue shift. And the term hyperchromic means the effect described the increase in intensity of light, and hypochromic means decrease in intensity of light. For identification of a compound by using UV spectrophotometer, in the spectrum we should have the following information. Uh, every UV spectrum recorded should have two absorption maxima appear at specified wavelengths for positive identification. After any spectroscopic analysis, UV spectroscopy, the graph have two maxima and at specific wavelengths to make the positive identification of compound. Also, the absorption maxima required to be within a specified range for positive identification. That means the functional group present in compound have a unique UV maxima or absorption that can be used for its identification. And in general, the solution should be uh, aqueous solution, besides it is dilute and free of interfering metals, should be aqueous, and generally we use polar organic solvent such as methanol or ethanol because they are UV transparent, and they are suitable for UV measurement. UV measurement. They do not absorb the UV light. The application of ultraviolet spectroscopy for identification of phytochemicals or for identification of natural products in general. The pharmacopoeias mentioned the ultraviolet spectroscopy as uh, identification tool or as quality control method for identification of natural products. For example, the BB, British Pharmacopoeia, use ultraviolet absorption to characterize as characteristic standard for enzyme penicillin because it's natural compound, lanatocytes, which have a cardiotonic effect, and for a number of alkaloids such as morphine, reserpine, cocaine, colchicine, and tubocurarine chloride. All these are stated in British Pharmacopoeia as standard quality control test for this type of secondary tablet. Also, in British Pharmacopoeia and EB, European Pharmacopoeia, test the coloring power of rosine hibiscus saberifa اللي هو الكركديه by measurement of absorbance of water soluble extract at 520 nanometer. Similarly for acid extract of red polymeters at 525 nanometers. That means BB and EB using absorbance at specified maximum for the colored rosy extract and for red bobby beaters as a standard identification method. This is an example of using UV spectrometer for determining natural products, mainly for identification of polycarbonate hydrochloride in water. Polycarbonate is a non-lactone alkaloid that isolated from the leaf of Polycarbus uh, jaworandi. Its UV spectrum, polycarbonate in water exhibit the lambda mass at 215 nanometer and in 0.2 normal sulfuric acid, also the same maximum at 215 nanometers. So in order to determine the spectrum or the functional group present in natural compound, we perform UV spectroscopy in two solvents. In case of polycarbonate hydrochloride, we check its lambda mass in water and also we check the lambda mass in sulfuric acid to ensure or to confirm that the presence of the functional group or chromophore can be confirmed by using two solvents. Infrared spectroscopy is another type of spectroscopic techniques used in identification or determination of the chemical structure or isolated compound. IR used to identify the functional group present in the molecule by analyzing how they absorb infrared light. Because the absorbed light causes nuclear vibration, make change in the molecular structure of the compound, and this vibration is unique for a specific bond and functional group present in a molecule. That means the vibration of carbonyl group is different from vibration of carboxyl group or different from amino group. So we use this vibration and the change in the infrared as response for identification of. In the principle of IR spectroscopy, as we said previously, when the molecule absorbs infrared, the molecule start vibrating. So the vibration results in stretching of molecule or bending or twisting of molecule on his own chemical bond. The resulting absorption pattern for IR can be unique for each molecule and result in IR spectrum. In IR spectrum or infrared spectrum or graph, we have two axes. The x-axis represents the wave number, centimeter minus 1, and the y-axis represents the transmitters or the transmission of UV so IR light, because when they are spotted on molecules, a part of IR is absorbed and the remaining is emitted or passed through the molecule. The IR spectra detector or detector, yes, can measure the change in the composition of IR wavelengths. So each compound have unique graph or spectrum represent the functional group present in the molecule at a specific wavelength number. In general, the area below 1000 centimeter, 1 centimeter minus 1 is known as fingerprint area. In general, the IR spectrum can be divided into two main regions. Region 1 is at the wavelength number from 1500 to and above. This is considered as absorption band for individual functional group, and it is used for identification of the molecules. The other part is the region below 1500 centimeter minus 1. This contains a band to characterize the molecule as whole, which is known as fingerprint region. So the fingerprint region is area below 1500 wavelength number. The use of fingerprint region can be used to identify substance by comparing the sample with authentic sample, and in most cases it is more useful than using melting point or thin layer chromatography. Here is the example for IR spectrum for acetone molecule, and as appeared in the spectrum, the region below 1500 is fingerprint region. This area fingerprint region, and when the molecule or the absorption of IR increased, then with the higher molecule, they shift for wavelength number towards the lowest wavelength number. And as appeared, the carbonyl group occur in region above 1600 wave number, while the CH group occur in the region below 1600 wave number. The general overview of characteristic absorption of the functional group in functional group region. The absorption is stronger between two atoms, the higher the vibration frequency. As the bond between two atoms becomes strong, so the absorption and vibration become higher. So the triple bond absorb higher wave number than double bond and single bond. The triple bond having wave number at 2200, and bi bond having absorbance in 1640 centimeter minus 1, while for single bond the wave number is 1000. Also, the aromatic nuclei or aromatic nucleus having a wave number between 1500 and 1600, while carbonyl group having a range from 1650 to 1780 centimeter minus 1. Alcohol groups and phenol hydroxy group. For free hydroxy group, having uh, uh, wave number from 3000 3650 to 3590, while the bonded hydroxyl group having a wave number from 3600 to 3200 centimeter minus 1. The IR spectroscopy is employed by pharmacopoeias to identify the isolated natural product. For example, the BB pharmacopoeia use the comparison of IR spectra for phytochemicals such as bilocarbene and phytostigmine with European Pharmacopoeia chemical reference substances, اختصارا EBCRS, as test of identity. So the BB Pharmacopoeia compare an infrared of some phytochemicals with uh, a reference sample of reference substance reported in EBCRS as test for identity. Here is IR spectrum of bilocarbene hydrochloride in potassium bromide disk. It is worth mentioning one of the important instrumentation or principle of using IR spectrophotometer is the use of potassium bromide disk. In this potassium bromide disk, we mix the sample, the powder sample, to be analyzed by our IR spectrum. As appears in spectrum, the molecule of bilocarbon hydrochloride having NHCH3 frequency in the range of 3080 and 3020 centimeter minus 1. This region for CH3 and this functional group, and also for aromatic stretch. That means the bilocarbon contain NCH3 connected or present in aromatic group. In the region of 1070 to 1770, we find the frequency for carbonyl group that occur in the lactone ring, alpha-lactone ring. This functional group appear in IR spectrum in the region 1770 in this area. Okay. This signal for carbonyl group present in lactone. And the pi bond of aromatic stretch occur in the region 1620 in area close to carbonyl states, also close to this area. And this is for the pi bond or carbonyl or carbon pi bond link between carbon atoms. The third type of spectroscopic technique is use of nuclear magnetic resonance for identification of natural product compound. NMR used to study structure and the dynamics and interaction of molecules. NMR influence magnetic properties of certain atomic nuclei when exposed to external magnetic fields and radio frequency. So, NMR use radio frequency to affect uh, atomic nuclei of carbon and hydrogen both present in the molecule in order to determine the chemical nature of this compound or this molecule. The principle of NMR spectroscopy based on the following facts. Uh, Firstly, the nuclei of hydrogen or the carbon 13 atoms possessing spin and behave like small or tiny magnets. When these small magnets or these atoms placed on a strong magnetic field, they ally with or against the magnetic field based on the charge that they carry on. So, the applying radio frequency pulses cause these nuclei to flip their alignment, and the energy emitted during the relaxation can be detected and analyzed, which result in NR spectrum. The energy emitted from relaxed atoms result in NMR spectrum, which is unique for each molecule. In NMR spectrum, for example, HNMR for ethanol, we find in the y-axis the chemical shift, which is reported as delta or part per million, and for y-axis we find absorbance. In the spectrum, we have unique spectra in specified chemical shift according to the nature of compound. And each signal may consist of one or more signal according to number of hydrogen or proton present in the molecule. The measurement in NMR apparatus, the measurement of chemical shift, always is relative to standard, which is usually tetramethyl silane or TMS, اختصارا, which is an inert compound which can be added to sample solution without the likelihood of chemical reaction occur, because these inert compounds have no interaction with the radio frequency waves. In NMR, the chemical shift measured in either delta or tau. In fact, tau equal 10 delta, and 1 delta equal the difference in absorption frequency of sample compared to TMS reference standard multiplied by 10 power 6 radio frequency. And the unit for delta is in hertz unit. Since the total radio frequency applied or used in NMR apparatus are usually 60 megahertz, and the shift measured in hertz, so the chemical shift referred to as PPP, or the delta, you say delta or tau or PPP, and here part per million, which means megahertz is equal 10 multiplied or 10 by power 6. Another important instrumentation for NMR spectroscopy is the use of inert solvent. Solvent used for NMR measurement should be inert and without protons, because not interfere with the reading of the apparatus, and we usually use deuterio chloroform اللي هو CdCl3 deuterated chloroform without proton, or deuterium oxide D2O, or CD3 or deuterated dimethyl sulfoxide. When comparing NMR to mass spectrometry (MS), is that the advantage of NMR is the sample can be recovered and used for other analysis or other tests, while in MS the mass is may be damaged or deteriorated and not useful for further analysis. The another type of NMR spectroscopy is carbon-13 NMR. Carbon-13 NMR considered as complementary to proton NMR or hydrogen NMR, and the combination of two techniques provide a very powerful means of structural elucidation for new compounds, especially for terpenoid, colloid, flavonoid, and so on. As in proton NMR, the resonance or the signal in carbon-13 is much greater, and the signal also appear in the range from 0 to 200 bar per million, downfield from TMS, trimethylsilane, as standard. Compared to proton NMR, the resonance range for proton NMR from 0 to 10 parts per million. That means the carbon-14 NMR are highly resolved compared to proton NMR. And the other characters for carbon-14 NMR spectrum is a molecule can assign to be a separate signal. Carbon in carbon-13 NMR appear as one signal, while in proton NMR may appear as singlet or doublet or triplet. Also, as proton NMR, the carbon-13 NMR substituted carbon give shift with specific range based on the nature or the type of the carbon atom. For example, aliphatic carbon atoms always showing shift between 0 to 40 ppb, while aromatic carbon-13 aromatic ring show a shift on the range between 110 to 150 part per million, and ketonic carbons show a shift between 160 to 230 delta or part per million. In this slide, there is an example for alkaloid showed carbon-13 NMR to TMS as internal standard. The compound is known as cybersine, It is benzyl isoquinoline alkaloid, belong to family Fumaraceae, and we know the chemical shift for carbon 13 NMR. The chemical shift ranging from the highest range or highest shift to 101.5, which is denoted for carbonyl carbonyl carbon. And as we said, for carbonyl ketonic carbon ranging from 160 to 230. And the others chemical shift we note 119.9 and 45.8 and so on 104 147.4, and all these in the range of carbonyl group to occur on aromatic rings. And as we know, the range for aromatic carbon from 110 to 150. One observe all the carbonyl occur in aromatic ring in the range from 110 to 150. The other aliphatic hydrocarbon ranging from 0 to 40, this methyl group, 39.7 and also 29.9. These are aliphatic carbons. An example for application of NMR spectroscopy in identification of natural products. There are several examples for the use of proton and carbon-13 NMR in this field. And NMR, proton NMR spectroscopy, has used in pharmacopoeias or in literature for assay of atropine and hyoscine in extract of belladonna, hyoscyamus, and stramorate. As we know, all these three plant sources considered as source for atropine and hyoscine. Carbon-13 NMR also used to distinguish the exudate of various resin reducing families. Through identification of carbon configuration of these resins can be used as a tool for comparison and to distinguish these exudate. Also, carbon 13 NMR with proton NMR are used to characterize exudate from Venus plant belonging to family Vinaceae, and also for other coniferae families, including Cupressaceae, Araucariaceae, or Podocarpaceae. All these producing terpenoidal compound can be identified by using IR, NMR, carbon 13, and proton. In this lecture, we talk about identification of 5-methyl dihydroflavasperone compound isolated from Sudanese plant known as Glira senegalensis family Combates. Is given as an excellent example for application of proton NMR and carbon 13 NMR for identification of natural products. For the proton NMR of 5-methyl dihydrofuranone compound, after purification of the compound by using chromatography, especially TFC, resulted with 5 milligram of pure single compound. Its physical characters is brown crystalline compound. After performing proton NMR for this compound, and we compared the obtained spectrum with reported compound in literature. The compound is previously isolated and characterized from the same plant by other authors. As we said, identification of new compound is or determination of new compound may be either of two conditions or two situations. It is a new compound which needs further identification اللي هو ال NMR carbon 15 carbon protein NMR COSY and so on. Or when compared to literature being an old compound just rediscovered or re-isolated. So in two cases, we use carbon NMR to determine or elucidate the structure of the compound. Here's an assignment for comparison proton NMR for 5-methyl dihydrofuranone using CDCl-CD as solvent. And when we compare the result obtained for isolated compound and for result reported by reported in literature, we find the similarity in chemical the position or the position of the signal for proton NMR. There is similarity in all signal of proton NMR, so resulted with the conclusion that the compound is typically reported in literature. Also, when performing carbon 13 NMR for this compound, the 5-methyl dihydrofuranone, and when we compare the result obtained by an experiment to result obtained by other author, we find also the results are typical to that reported in literature. The compound consists of 10 carbon atoms with the same chemical shift or position. After we compare the carbon 15 NMR and proton NMR obtained to result reported in literature, we end with structure of the compound 5-methyl dihydroflavasperone, which is an aromatic compound with byron ring. The last spectroscopic method used for terrestrial elucidation is mass spectroscopy or mass spectrometry, and known as MS. Also, it's considered as analytical technique used to measure the mass to charge ratio of ions. and mass charge ratio reported as m divided over z. Mass m for mass and z for the charge. Uh, Mass spectrometry is used to identify the composition, structure, and chemical properties of substances. And mainly it's used for determining the chemical or the molecular weight of the compound based on the fermentation pattern obtained from a molecule when placed in electric field. And the principle of mass spectrometry, uh, the sample or the molecular sample is placed in when placed in electric field. The electric field result in ionization of the sample, resulted in ions, and each ion having speed or movement depending on their mass to charge ratio. When plotting the mass charge ratio to the relative density of these ions, we obtain the MS spectrum. For example, this mass spectrum for methyl 3-pentyl 2-on is a keto compound, and we note in the x-axis to find mz ratio, mass to charge ratio, and in y-axis we note the relative density. And the compound have unique signal in specified mass charge ratio and having a relative abundance or density according to number of ions present in the field after ionization. And the highest signal with the high relative intensity known as molecular ion, which considered as the molecular weight for the compound. An application of mass spectroscopy in elucidation of phytochemicals. The method is used or usually associated with structure elucidation of the isolated compound, and in the field of natural laboratory chemistry, the simultaneous use of two mass spectrometers in series, known as tandem mass spectroscopy or MSMS. This simultaneous combination can be useful to determine quantitatively the amount of particular compound that present in complex mixture, especially in plant extract or in dry plant material. When we're comparing the spectroscopic techniques, including UV, IR, NMR, and mass spectroscopy, in background of complexity, we find that mass spectrometry and NMR are more sophisticated and more expensive, which should be operated by trained personnel. While IR and UV spectrophotometers are less expensive and can be easily handled or operated by phytochemist itself. So, in research, the phytochemist should hand his sample over to for analysis and just give reviews about the result in form of graph because it is more sophisticated and sometimes it's impossible to be operated by a phytochemist. The two volatile compound to vaporize in mass spectrometry can be rendered or converted to volatile form by derivatization with trimethyl ethers or methyl esters or other similar derivatives. And generally, mass spectrometer used in conjunction with GLC, gas liquid chromatography, which is used for volatile compound. And this combination between GLC and MS provide comprehensive or useful qualitative and quantitative method for identification of many structurally complex compounds that may present together in particular plant extract. In this slide, another example of naturally occurring compounds that its structure can be elucidated by mass spectrometer. The name of the compound is isobentyl aminofluorine or trans this compound containing uh, amino group with uh, heterocyclic ring. This heterocyclic ring and amino group. Zeatin or trans zeatin is natural occurring cytokinase as growth regulator isolated from higher plant. In mass spectrometer spectrum for this growth regulator, we find the predominant or the N plus ion is at the position between was the pressure 219, this molecular ion 219, this position, and primary alkyl alcohol can be short into MZ regions in 202 and 188. This for primary alcohols. Also in the position or chemical shift or mass charge ratio at 148, and this indicates for alkyl group attached to N atoms. Okay. Finally, the conformation of adenine nucleus obtained from characteristic fragment shown by most adenine derivatives at 136, 135, and 108. In this position, 135, 136, and 180. These are assigned for adenine nucleus or the heterocyclic ring of the compound. The advancement in mass spectrometry allow the apparatus for to identify the polar and non-volatile salt can be detected, especially when fast atom bombardment the FAB source is added, then the compound can be useful for analyzing fragile or involatile compounds. Also, the advancement in FAB source makes the MS useful to identify glycosides, especially O glycosidic sugars, which lost during the process of fermentation. Now it is possible by using FABMS to obtain molecular ions for original glycoside or the intact glycoside. Of mass spectrometry and elucidation of naturally occurring compound, the use of tandem mass spectrometer or MS coupled techniques can make the instrument or the method more or highly sensitive for picograms of target compound with high specificity. Another way, the tandem mass spectrometer is highly sensitive for uh, target compounds with high specificity. Because of this higher sensitivity and specificity, tandem mass spectrometer used for analysis of cocaine in plant material, and as we know, cocaine in low concentration or trace concentration uh, considered as abuse drug, and its distribution is restricted by or limited by regulations or by rules. Also, alpha toxin B1, which is considered as higher toxic natural compound in peanut butter, can be detected by tandem mass spectrometer. Also, taxol and baccatin, which are known as famous anti-cancer agents that occur in Taxus gravifolia, can be detected by using tandem mass spectroscopy because they are highly expensive and used as anti-cancer agent. Bilocarbine also used as an example for use of mass spectroscopy for identification of natural compound. Uh, the BB or the pharmacopoeia in general use bilocarbine or use mass spectrophotometer for bilocarbine identification. There are different MS spectrum in pharmacopoeias for bilocarbine as base and bilocarbine as HCl salt and bilocarbine as nitrate salt. Definitely each one have a specific molecular weight and molecular formula. In this MS spectrum for bilocarbine as base, and we show that, and the molecular ion or N plus ion for uh, bilocarbine is 200 208.25, as which means that bilocarbine as base. At the end of this lecture, we conclude that the structural elucidation of natural products means the use of spectroscopic method to determine and identifying the chemical structure of secondary metabolite isolated from plant and from marine organism. The type of spectroscopic techniques used including UV, IR, NMR, and mass spectrometers. The structural elucidation can be involved in two steps. Step one, determination of molecular formula or molecular weight by using elemental analysis, and this mainly can be achieved by mass spectrometer. And the other step, or the second step, is determination of the chemical nature or type function group present by using a UV, IR, and NMR spectroscopic techniques. Uh, in lecture, we talk about two main topics: preparation or isolation of purification of isolated compound before spectroscopic analysis, and we speak about the principles and application of UV, IR, NMR, and MS in the field of natural product chemistry. And as we said, it is very important before to determine the identity or the chemical structure of compound. We make sure that the isolated compound is pure single by applying the sample in different chromatographic systems, including TLC, HPLC, and GC, besides determining physical and chemical properties.